Hi there. I am Mimir, and in this episode, we present a masterclass from the group managing director of a global tech company. We have separated our conversation with him into two parts, one of which is technical, where any engineer, young and old, can learn from, and the other, a leadership conversation about his journey. Look out for the timestamp so that you could jump to the conversation you like most.
Every machine that we build is unique and special. We have made a promise to our customer that whenever we make a machine, we will produce something reliable, accurate, rugged, repeatable, and until the machine complies, we are not able to stop. This is at the core of who we are. There is something special about the act of creation, of taking an idea and turning it into a tangible product. There is nothing else I'd rather do. And when I see the products being used internationally by our global manufacturers, I'm reminded that all the hard work is worth it. I'm grateful every day to have found a career that allows me to channel my passion into something that has a positive impact on the world and the people around me. This is truly a blessing.
The first time we shipped it. And so you can't just pick it up in the middle from those hooks. You actually have to, that's why we've got designed hooks over there. So you strap the machine and you pick it up so it doesn't bend.
Yeah.
So you lift it up with a big crane. So I remember I walked down the stairs and the first machine was in the air.
Going to Pamplona.
Going to Spain. And I walked back into the office. I don't want to see anything go wrong. Let me just go inside. Because this thing is swinging, what is it, 11 tons? 11 tons? Swinging in the air, hanging from these straps. And it took so much emotional effort to get it working that I didn't want to, I just would not be able to handle anything happening.
Quinton, thank you very much for coming to the show. We've been wanting you for some time now. There's a picture that I have in my mind of young Quinton, a colored boy in South Africa during the Apartheid era. And I mean, I wasn't in that world, so I don't know a lot about it, but I've heard about it. And you fast forward a couple of years later, he started a business in those times. And 30 years later, he's selling production lines more than 10 million euros to Europeans and Americans and Chinese and Asians. And I'm thinking in my mind, there are people who have circumstances and they think that they can overcome, but you overcame that. What type of a person must you be to achieve that?
I don't know. Type of person I was just one that was hardworking, and I think curious and had a dream. Okay, but a lot of it as well was driven by, strange enough, insecurities. Okay, growing up in the Apartheid era, you were made to be second-rate. A lot of the time, that's how you felt. You weren't allowed to go certain places. You weren't to go to good movies, restaurants, movie houses, restaurants, beaches, things like that. So it was always, it played on one's insecurities. But those insecurities in my world, it worked for me because it made me work harder. It made me do more things more often, try different things. And yeah, I think the net outcome of a lot of bad circumstances, whether it be family, a difficult upbringing, the system around you, it just made me work harder to prove that I am good, which had a lot of net effects, negative as well, in my life after that. But yeah, I think it was going out there and doing something and proving to yourself that you are worth it.
So I look at South Africa as it stands now, or as it's described in the media, the political instability and jobs, unemployment, and the crime. And I'm looking at a young person who is in their head, they're thinking that I am like this because of the sum total of the environment. And I look at your situation on how hectic it was. You couldn't go to certain places. You were segregated according to the color of your skin, but yet you decided to start a business. How do you put that into the young person in today's world?
So growing up, my dad always had his own business, he eventually landed up with his own business. And I think that was the one thing that was different, even through all his trials and tribulations with his business and his struggles. It was something that was there. And I knew I could see the benefits that it could give you in some places. The circumstances as well, that from the apartheid era, some of it gave me some opportunities when things started to open up, when it was getting a job at General Motors, working in a corporate environment, seeing that I didn't like it. It didn't fit in at all. I never felt comfortable. It just wasn't my scene. And so early on I knew that I needed something different. I didn't know it was I'm going to work for myself specifically, but I needed something different. And then a series of crazy events led to me opening up a business. I won an award for a design program, of a design that I did. And for my first job, I negotiated a really good salary and, very importantly, a CAD workstation. That was foremost on my mind. I wanted a CAD workstation. And then my wife and I started this business doing, converting people's physical drawings into digital copies of it for AutoCAD. So it was a series of strange events, circumstances that kicked me off into the right direction. It wasn't really a thought of, I am going to do this and I'm going to land up in automation. I never knew where I was going to land up. I could only see so far ahead, like headlights don't bend around corners. Well, actually they do, but standard headlights don't actually see around corners, and you can only see so far ahead. So it was out of necessity of some of the things. You had to survive. You had to make a way. I had a young family, and so there was no other options but to work hard, and it got me where I am.
So Quint, this is a very famous machine at Jendamark.
Yes.
Both you and I have had literally blood, sweat and tears on this machine.
Yeah.
Maybe just talk to us about what is this machine. I know David was one of the key designers. You worked very closely with David and a lot of the other guys to get it to what it is today. But what is it? What are the key functions? Then we can talk about some of the design elements.
Okay, so in a catalytic converter, we have three parts that are unknown in their dimensions. Okay, we have the monolith, which can change anywhere plus minus a millimeter. We have the mat, which is a thickness variation, and then we have the stainless steel can. Okay, so the stainless steel can comes in oversized when you're doing soft stuffing. The mat we measure and weigh so we can understand how thick it is. All for a monolith, which size is undetermined. Once we measure that in the measuring machine, which we can talk about a little bit later, is that we wrap the mat around this and around the monolith and slip it into the stainless steel casing, which is going to be the body of the catalytic converter. And then this machine, together with some computer assistance, decides what the stainless steel casing size should be to hold that monolith in place with the process and a protocol called GBD, gut bulk density, to hold that in place for the lifetime of the vehicle. So what this machine does, it takes stainless steel sheeting or tubes between 1.5 and all the way down, very importantly, 0.8 millimeters, she can also do.
And tested on 0.6?
And tested on 0.6 as well. And plastically form the stainless steel around that monolith with a mat to set it in place and dimensionally change that up to 7 millimeters. So that's what that does. It's a huge, it's a shrinker, it's called a shrinker, but it basically presses in a circular or an oval shape, shrinking a size down of a can to
compresses that can down to
the size that you need.
So there's obviously a couple of key processes on the machine. So maybe describe the how does it actually collapse the can down?
It's a very mechanical process. Once We know the dimension that the can has to be. The can is fed into the tooling set, and just by a set of wedges driven on this head, we are able to, by virtue of the two servo motors and the planetary roller screws, draw the head in and make the wedges collapse onto the component. Very importantly, we can also do not just round parts in this, we can do ovals, we can do rovals, we even feel confident in doing the dreaded kartoffel or the potato shape as well.
So obviously the ability to be able to do the non-round components is because of the stability of the drum.
Yes.
Maybe just talk to us about the process that you and David and the other guys went through to actually establish the manufacture of this drum, because it's a key part of the success of this machine.
Yeah. So it came down to a real rigid system in the head. It's larger than, I'd say, our competitors as well that have also used this type of technology. But it's larger because of how we deal with the actual location and the constraints that we put around the sliding mechanisms, not to move out of place, and that's why we can do all different shapes. It's a very accurate machine. There are some tolerances here which we have set up for us to be able to do all the way down to 0.6 millimeter stainless steel.
So obviously you need to set those very tight tolerances to avoid any movement in the segments. That creates the stability which allows us to do much more complex shapes and these very thin materials, right?
So the tolerance, the type of tolerance is not just for the sliding mechanisms themselves, but it also translates to your jaws, your teeth that are coming in that press onto the component and actually deform it. So if you can imagine, if one was sitting ahead of the other one and it was being pushed in, it would create a pressure line and it would destroy the monolith because that stainless steel would kink on that line and it would be a complete failure.
Quinton has got a special Quinton measurement.
So this is the shrunk component, okay? And the most important thing for me is you must be able to see the witness marks of where the tools actually touched, okay? But you're not able to feel it, okay? And that's it, very roughly is and I'm talking about very sensitive fingers here, okay? Not be able to feel the ridge lines.
I'm convinced men are more sensitive. They don't have the experience.
So earlier we were speaking about, when Quinton walks on the floor.
Yeah.
And there's something going on at one of the shrinking machines we're delivering for a customer, and Quinton does this, and then his tongue comes out. It does this, it starts biting. You can just see everybody's like, oh shit. And then when he feels something, the tongue, he starts to bite the tongue. And he's like, his fingers are like really feeling it. And then everyone's like, oh
it's done,
shit.
it's over.
It's over.
So, but how does this thing come in? Does it come in like this?
So it starts out at this diameter, and we've shrunk it down. You can see the step down.
Yes.
We've shrunk it. This machine shrinks that part down to secure that in place. That's basically it. Quinton, I wanted to ask you a couple more questions on this. So this is a forged ring.
Yes.
What is forging?
So forging is when we actually take the industry takes steel and actually hammer it into place, creating a tighter bond structure in the crystals, and it's a much tougher, much stronger. So things are to be forged or axle components where you need strength and durability. It's just a much stronger component than just normal steel that would be cut. So we use the forged ring to be able to manufacture this, and that's why it's so rigid and why it's so sought after.
So obviously the driving mechanism for basically pulling this big collet over the tools is two roller screws as well as the servo motors that are driving each screw. What's the difference between a roller screw and a ball screw?
So a roller screw is a much finer and more precise, shall we say, rotary instrument. A ball screw has a nut, as does a planetary roller screw. But a ball screw, if you can imagine, is a row of balls sitting in a groove that is cut onto that ball screw and ground. And you've got these very, very small areas where a ball is sitting in, and a very small space for it to ride onto. So the loading that we put onto these here, we don't feel comfortable using a ball screw because we want longevity on this. In the planetary roller screw, there are a set of planetary rollers sitting around, 9 of them, around that ball, around the nut with a very fine thread. And so you have multiple facets actually making contact with the screw, which is in orders of magnitude more than the actual ball screw, giving us a far smaller component that we can actually drive higher loads with.
So one of the debates we had was, obviously you can spec a planetary roller screw or a ball screw and still achieve a load. But one of the key drivers was the duty cycle and the longevity of it. Yeah. Maybe just talk to us. So, because I mean, it was one of the debates we've had. Should we use a ball screw?
So it's far cheaper. So if this was up to a finance person, he'd put in a ball screw. And
like we're talking about 30,000 euros times 2 versus 5,000 euros times 2.
Yeah.
So it's not
that's a significant.
It's 60,000 euros versus 10. It's not an easy decision to make. And the reason why I'm kind of bringing it up is because engineering has to come first. If you're making machines, engineering has to come first. And this is one of the key strengths of Quinton, is that it actually makes the decision based on the technical, not the finance, which is not so easy to do when you take your money out of your pocket and put it out there, right?
And for instance, when we bought this machine, we did this out of our own pockets, okay, to prove to the world that we had a good product. So it was straight after the credit crunch and the recession, and so it was a very difficult decision to make. But if we were going to be taken seriously, I don't think it would have been with elements like ball screws. We had to go out with the finest product in the world, and yeah, that's what we did.
Some of the two challenges I'm going to ask you about, again, it's easy for me because I know the challenges, was about synchronization of the motors. What happens when the motors turn and they're not synchronized? Unfortunately, we felt the technical pain and the cost pain of this.
So because it was a very new product to us, we made some mistakes along the way. So you can imagine the power that we can deliver with either of these and then going out of sync, which means one drive stops while the other one continues, and they're all running on that set of linear rails. It's an unholy mess because this entire head gets slewn through an angle, and it's
and everything breaks.
Everything breaks. So we've had those pains, but then we've learned how to choose our products, how to put in the safety systems, because that first prototype was a nightmare. It was a birthing process, not so much the commissioning of a machine. It really was a birthing process.
So how much of the stuff that is on this machine is actually bought and assembled, and how much of it is built in-house? I don't know if that's a... I'm just thinking about that.
Yeah.
The things that you would be buying out are things like the PLCs and the controllers for the servo motors that you see there. But all the steel structure, the design of the heads, the actuators, these units, actuators would obviously be bought out from suppliers like Festo.
So I guess as a rule of thumb, all the electrical items are bought out. The pneumatic items are bought out. 99% of the mechanical elements are designed, manufactured by us. And obviously the putting it all together is done by us, and obviously programming it, making it work.
So the IP is the design?
That's right. The biggest thing is the IP
design
and the process of manufacture.
I think it's more than that. I think the IP is the design, obviously the process of manufacture, but to assemble this thing is not, you can't just give somebody a document and say assemble this. There's a skill that's developed over time, that's IP. The way you program the machine so it doesn't break itself, so that a customer can add and change variants themselves. That's a know-how we've learned over time, also through mistakes. So I think there's IP at different stages of the process, and altogether, it's been our baby. It's been the thing that changed our company.
So a lot of people, again, they ask, or make the statement, you export machines or production lines, and yes, we do to a large extent, but most of that is IP related. Okay, something that we retain in house and can use that again and again.
Yeah. Talk to us about maybe one or two of the incidences where we've made mistakes with lubrication, and why is lubrication so important in a machine like this?
So you can imagine this is the lubrication system, and it needs to be, the entire system has to be charged, and where we made mistakes was also on the grooves that we had to cut inside of the facility with these sliding mechanisms that developed these high forces. So that was a learning all on its own. We got that wrong and we seized up machines.
So you can imagine two pieces of metal sliding against each other under a huge force with no lubrication. It gets hot, then it seizes, and then it stops.
And there was an easy way to take care of it, was to actually make slipper rings out of bronze material and with graphite impregnation. But that would mean that my customer would have to replace those on his own. So we went for the more difficult way of steel on steel with lubrication grooves. And we learned a thing or two along the way.
And maybe talk to us about trying to cut the little thin grooves through the tooling so that the lubrication can get everywhere. How many drill bits did we lose?
So the processes, we tried deep drilling, but it didn't work. We eventually went to EDMing, which is electro drilling of the holes to get, because you're looking for very, very fine diameters, but long distance, and there are ratios which you cannot exceed when you're doing drilling. So that was a big learning process on our side.
I'm actually realizing that from boardroom to shop floor, the theme is passion. I mean, the way you guys are describing this, it can only be passion.
So maybe tell the story about what you did to me on this machine.
So
one thing I'll never forget.
No.
It was worse. It was worse.
So there's I actually have it in my office, is a crushed can. We had the customer arriving the next morning, and I had taken the night shift to make sure that the machine, and you were going to come in at, what was it, 6 in the morning. We sorted the machine out and got it finally running beautifully at around 4 or 5 o'clock, but not after a couple of mistakes. And one of these we completely crushed the can. Okay.
Like it looks like
it mangled.
Meshed.
Okay. I took that can and I said, on the can, I think I remember writing something, if the can looks like this, imagine what the machine looks like. And I left it at his door of his office. But obviously we had packed out all the components beautifully here with all the sizing and the reports of them. And I went home, and he came back the morning to see the can, and I knew what his imagination was going to do with him. It destroyed him, and he rushed down here to come see the disaster.
No, well, I stood there for a moment. I'm like, maybe I might just go home and sleep, because I didn't have much sleep the night before. So I was like, well, if this is the state of the can, I can only imagine what the machine looks like. Customers coming, I'm done. I can't anymore.
Yeah, we were on the last. It was close, that one.
But
anyway,
somehow we made it.
Yeah, pulled it off.
Yeah.
Had an amazing team working through the evenings.
24 hours.
24 hours.
What I can tell you is you can actually have a full cricket pitch in here.
Yes.
And I was actually pretty good at bowling.
Off
Off-spin on the shop floor.
The ball came from all the masking tape from setting
from
up.
the machines. All this masking tape, you tape one side of the ball, and while the program is busy, off-spin.
Yeah.
Okay, Quinn, so thanks for giving us a rundown of this machine. We're going to move to the successor of this.
So if we're going to talk about the successor of this, just keep in mind this one is about 5 meters by around 2.5 meters in width. Our customers overseas love the machine but don't like its size because real estate is
sorry,
really
I forgot to ask a
expensive.
question. Why is it that size?
What's this?
That size.
5x6.
So it can
Five
fit,
point-
remember it was we
yeah.
designed it so it can fit in a container.
Fit into a container. Okay, we gave ourselves that luxury that we're going to go horizontally with it through. Is what we felt was necessary at that time, and we made sure it was containerized so we could put it into a container.
Also remember the first time we shipped it. And so you can't just pick it up in the middle from those hooks. You actually have to, that's why we've got designed hooks over there. So you strap the machine and you pick it up so it doesn't bend.
Yeah.
So you lift it up with a big crane. So I remember I walked down the stairs and this, not this one, the first machine was in the air,
Going to Pamplona.
going to Spain. And I walked back into the office. I don't want to see anything go wrong. Let me just go inside. Because this thing is swinging, what is it, 11 tons? 11 tons? Swinging in the air, hanging from these straps. And it took so much emotional effort to get it working that I didn't want to, I just would not be able to handle anything happening.
Dude,
But yeah.
you guys are hardcore, man.
So the criticism of our customers was the old shrinker, as good as she was, it was a large machine, took up a lot of real estate. And we started looking at other ways of doing it. And we started following some principles of the process of how we handle components, what is the best way to do it. Most of that, the components are handled in a horizontal position. We've long been wanting to do a vertical machine, and so now we have our vertical machine. So it's basically 800 by 800 with the tooling set in, and it performs all the tasks that one does, all the way with the lowering and raising the component through the entire tool set without digging a hole in the floor. So this came out of the R&D department. We developed it there, built it, tested it, and now are now selling it.
So obviously one of the other drivers is cost.
Yeah.
So-
Needless to say, but like I said, the first criticism was
The size.
of it. There's obviously only a single motor to this. It's an easier drive mechanism. There's no component for slewing, the issues that could arise before if maintenance wasn't done on the machine properly, and a much more cost-effective machine, much smaller.
There's obviously a couple of other elements. Obviously, as you can see, this frame around here is for the tool change, right?
Yeah. So tool change. The best tool change for us is no tool change, but in some cases that's not possible. In those machines, even in the CD world, our machine tool change is around 35 seconds, which is absolutely fantastic. We are now having a tool change which is around 15 seconds.
So what is the tool change on the passenger machine, more or less? It's all manual, right?
If I personally do it manually, it is 7 minutes.
And if a human does it?
7 minutes, 30 seconds.
I didn't say superhuman. Have you ever seen Quinton do a tool change?
No.
You need to film that. This is crazy. But so obviously tool change was a big driver of this reconfiguration.
Yeah, so this is the entirety of the actual shrinker, the vertical shrinker, and these are the tool change elements. We've aligned it so that you can load up your components, your
So you
next
drive a
tool.
trolley in, right?
You drive a trolley in here and a new one on that side there, an empty trolley and a full trolley, and it does the automatic tool change by just sliding it across. Okay. And so not only have we developed a shrinker in this, we developed a machine that can handle shrinking operations, end forming operations, expansion operations. So you can have them all aligned or in a different constellation, however you want to do a tool change.
Yeah, so from a controls perspective, I mean, it's one motor, which is a huge saving. One screw, already discussed the price of the screw, so there's huge savings on the screw. The machine is significantly simpler. I mean, when I look at it now, I'm like, why don't we do this first? It's like one of those things. But it took a couple of step-by-step, evolutions to get to this. And I mean, also I think one of the things that Quinton kind of alluded to upstairs is, having, empathy for the customer. So we could easily say that's the machine, take it or leave it. But understanding that they want to use smaller footprints, make machines smaller, more compact, improve the cost, the speed of speed of tool change. Those are all key drivers that is a key function of our R&D department, which Quinton is responsible for, and the outcome is this.
When you maybe talk to us about your journey at SKF and how you ended up being let's call it a design detailer kind of person, that you entered the ward into to designing machines that assembled elements of the SKF product, to being able to select the ball screw and a linear rail and all of that kind of stuff. How was that?
So my mentor then was, I'd come through other mentors like Mr. Carl Hoffman.
Where was that?
And that was at General Motors / Delta Motor Corporation. Very practical, down-to-earth engineers who dabbled and tried and nothing stood in their way. And I was very fortunate as well. Today we see a lot of catalog engineers. Everything comes out of a catalog and it's just picked and placed. These were another breed of men. They made everything. Yeah. That was the difference. So you learn to think not only about applying technology, whatever it was in those days. I mean, I come from the days where there were no PLCs. You only went to a PLC after you had 18 relays in a box, and then it made sense to go to a PLC. So everything was very, very designed and bespoke and made for a particular job. So you learn from those guys what it is to really design. Then I went over to SKF, and then it was a completely different ball game, from making cars to making circular things that go round and round. You learned all the processes, and what those guys taught us, or Mr. Schindler, Mr. Bachmann, was take care of the process, understand the process. Why are you measuring something here? It's because it has the process has to be measured all the way through. What are the important things to measure? Which flanks, which dimensions to take care of, what size balls must be in the bearings, the grading of balls, the grading of rollers, the types of steel that you use to make these things, and then the machines that we design to actually manipulate these things and will assemble these bearings, whatever they might be. So in that, you got to learn the choice of your components, the choices of whether it's an oval center toggle and a locking device or a wedging device to hold certain forces. I think we were very fortunate because there weren't any bought outs. We didn't have things off the shelf servo motors to hold forces. It was all fit and form and using geometry to hold things together. So very fortunate that way.
If I understand what you're describing is that you had to design from first principles.
Yeah.
You couldn't just assume from a catalog the calculations of a linear system were taken care of.
Yeah.
You had to design from first principles.
Yeah.
So you had to do the friction calculations and the rotation calculation, the ball screw size and the wobble of the ball screw.
Yeah, the length.
Whereas now, we just pull something out of a catalog and it works.
Yeah.
Or supposed to work.
Yeah, input some parameters and it's all done for you on the computer.
Yeah.
So I think a lot of that, if you don't do it from first principles, or at least understand how to do it, a lot is lost in how you apply yourself.
Yeah.
And when you are presented a problem where none of those things are applicable, then it's a big problem.
And also we find now, obviously, as we go through now, when you're trying to, when there's a problem on a machine or a production line and you now try to solve it, and you haven't understood the first principles, you're done. You're not gonna be able to solve those real challenging technical problems because you've just thrown a bunch of standard components together and you think it must work.
So if you don't understand the process whereby something is machined and what's important for its functionality as the product as well, you'll never be able to build a machine that can measure or assemble it properly. So this is a pinion nut tightening machine. A very important part of a differential is the actual relation and friction load between the pinion nut, the pinion shaft, and the crown wheel of the pinion for the differential. So this process here is actually tightening up the pinion with a set of bearings to create a preload with a collapsible space in between, which acts as a spring to create that preload, by tightening up the flange nut to somewhere around 750 Newton meters of torque.
Wow, it's huge.
And hence the huge motors that are up there, but also to deliver this preload, which we measure in friction at the end of the day in Newton centimeters. So 2 Newton centimeters of friction load for the preload.
So that's obviously important for fuel efficiency of the car.
Definitely. So I think when we started out on our journey, our previous differentials, which were with Gen 1 bearings, they were up to 2 Newton meters, and it was very tight.
2 Newton meters.
Yes.
And now we're down to 2
Newton
centimeters.
centimeters. So this all speaks to the efficiencies that are driven with the newer bearing sets. The Generation 3 bearings are the bearings now with angular contact bearings, as opposed to the taper rollers we used to use before. So yeah, it's a very important part of the process, and I mean this ensures that the fuel efficiency or the efficiency of the actual drivetrain, this is a key component of it.
So I mean every car is a differential.
Everybody has each one.
You mentioned preload of the bearings. Maybe just talk to us about what is preload and why is it important?
So preload is the load that we give to a bearing to keep the bearing set in place on a particular shaft. We create a preload by either having some spring load and tightening a nut to pull the bearing set together on a shaft in its housing to make sure we don't have any movement of that shaft laterally, as it were.
Okay.
And also to keep the bearing set in place. So especially on taper roller bearings, they are very loose fitting, so preload actually keeps the contact surfaces in a state that delivers longevity.
So it's
and precision.
constant for the life of the
Constant for the life. Yeah, that's what you're actually trying to do with that preload, to have a preload and for the life of the vehicle.
So you mentioned 2 Newton centimeters. Obviously must be some sort of measurement device inside here to measure that friction.
Yeah, so the principle of this machine, if you look to the top, you see 2 huge motors, okay? And one is engaging the flange of the differential, and the other one, the actual differential flange nut.
Yep.
Okay? And while the diff is placed on the unit here, we hold it centrally on its points, on that pinion shaft, as it were, and the differential is actually free to rotate and move and rotate around that bearing set. The only thing stopping that bearing, the differential from moving around, is a load cell set at a particular radius off to the side, holding the differential in place. So as we are turning the flange itself
at 700 Newton meters.
So it's not that at first, obviously. You're driving the flange and you're engaging the nut, and we tighten, have a differential speed between the two of them. One would be doing 100 RPM and one, say, at 50 RPM, until we see we tighten the torque to a particular torque, which we registered with a huge torque transducer inside on the nut. And then we drop down that speed, and one will be traveling, the flange will be traveling at, say, 60 or 50 RPM, and the nut would be then only be traveling at 51 RPM. So 1 RPM difference while you're actually tightening, and that is creating the load and the torque.
And that's turning the housing. And you actually measure the housing.
So as the bearing set gets pulled together, more and more friction will be set onto those bearings they will experience, and so create a rotational force on the differential, and the load cell set at a radius will then be resisting that, and that's how we can measure that friction.
I know one of your pet peeves that you drilled into my head over the years is how to select a transducer, whether it be a torque transducer or a torque transducer or a linear displacement transducer. What are the Quinton minimum requirements when selecting a transducer?
Let's pause the conversation there quick. What exactly is a transducer? A transducer is a device that converts a physical quantity, such as pressure, temperature, or displacement, into an electrical signal, such as voltage or current, or vice versa.
So, well, it depends on your electronic setup as well, and knowing how much resolution you have and be able to read something. Today it's much easier. We're not dealing with devices that are analog.
Yeah.
In those days, we actually had to choose a 32 or 64-bit device to see what resolution we could get in that. Today it's much easier with the digital devices, but I think this one is still analog. And it's about choosing your range of your component, understanding the accuracy of the transducer and your electronics to make sure that whatever the customer's specification is, that you are never more than 1/10 of that specification. So you have to be 10 times tighter than your customer's specification to make sure that you have a capable machine. Otherwise, you're dead in the water.
And I know that you always pushed for, if you're measuring a displacement, for example, you don't choose a 300 millimeter displacement sensor when you only need 30 millimeters, for example.
So yeah, horses for courses, because that 300 millimeters sensor will give you a particular resolution, and the 30 millimeters that you're measuring, you need to use a 30 millimeter range transducer to get the right resolution for you. So it's easy to say now, but it's a trap when you're much younger to fall into very easily.
So I'm going to ask you an electrical question.
Oh my goodness, okay.
Talk to me about noise on a transducer signal.
Electrical noise is unwanted electrical signals that can interfere with the intended signal in a circuit or system.
So again, not so prevalent nowadays with digital systems, but we've learned the hard way of electrical noise, whether it be welding systems nearby. You can imagine you're sitting with plus minus 5 volt signal or plus minus 10 volt signal coming out of a transducer, and the key is to get it into a digital format as soon as possible, or get it transformed into useful information. But usually on a machine there's a cable that has to run, and the path that you choose that cable to go near high powered solutions, power solutions, electrical noise from welding equipment, it can be an absolute nightmare.
Never run a 4 to 20 milliamp or 5 or 0 to 10 volts.
The 4 to
signal
20 milliamp was much better.
But next to a 3-phase 380 or 400 volts, and you put the two cables together and you wonder why the signal on the 5 volt cable is all over the place.
Yes.
You only learn that the hard way. There's no book that tells you to do that.
So as a mechanical engineer, I was also in charge of designing the machine and the cable routing. And there's many an electronics person that was angry at me for routing it the wrong way around. It burnt my fingers many times.
We all burnt our fingers many times. Too many times. While we're here, I was going to ask you on one of the other machines, talk to us about these things.
Linear rails,
Yeah.
in which respect?
Why? Okay, in your opinion, what's the right way to set up these two linear rails?
So we do it rather in a special way, in that we actually machine pockets for the rails, and then we are able to set in those pockets to be able to set it up to one side, tighten it up, and that machining tolerance will give us the accuracy of the rails, because the rails have a certain serpentine as well in the length of them as well. So we are able to set that up, take out any waviness out of it, especially not so much on these machines, but on our laser measuring machines, where the stroke that we are looking for is over a meter long, and our lasers are 0.5 micron accuracy to measure a monolith. And if you are wavy on that,
your expensive lasers
your
are waste.
expensive lasers are a waste of time. So even on these, on the measuring machines, we would use that and preload even the linear rails, not buy preloaded ones, but actually use 3 and preload them with an elastomer bearing,
Yeah.
so that the laser measuring tracks completely straight and straight down the center of the monolith, or our predicted center of our machine.
I'm imagining a young Quinton who specializes heavily in engineering and design, and he's an engineer. He has passion about
No, young Quinton specialized in nothing. Young Quinton specialized in trying and failing, and so I didn't know things. It's still a journey. So there was no specialization when I was younger, and there still isn't today. Sorry, I must correct you. There's no specializing. We're specialists now in machine building, but it's just one little portion. And like I said, back then I knew nothing.
So I have two questions for you, Quinton, that I'm really interested in. You are a trying engineer who's trying to figure it out, as you're saying, and then you guys with your partners are starting this business, but business is a different ball game.
Oh.
How do you? The first question is, how were you guys selling the first production line, and how did that happen?
So we started actually our first machine was a window winder mechanism testing facility for a company called Dorbel. You know the then managing director is now the managing director of SJM, Tion Joubert, and he gave us the opportunity to do a window winder tester where we were checking stall currents of the motors, vibration and things like that. And then we did a really good job on that machine. Then it was a little horseshoe cell of assembling jacks, making little bearing assembly machines to make thrust bearings. So they were onesies and twosies, and then a little horseshoe cell, and then maybe a small 5-cell assembly line. So it grew with it. It wasn't that we just got into the big leagues like we are today. It was a growth, a slow one, with lots of failures as well. We made lots of mistakes. I mean, figuring this stuff out from first principles it's not easy, and there wasn't anybody to show us on machine building to say this is the way you do it. There wasn't that.
So you guys have been on the sales force for a long time together. I'm still really fascinated on when did the baton get passed to Yanesh, or how did that happen?
It hasn't happened.
What baton?
The baton has been handed over. He just doesn't want to recognize it.
He doesn't want to say he has it on his hand.
I mean, like I said, we did all the small machines as Jendamark. Yanesh only came along, I mean, what year?
2004.
2004, yeah. So
19 years ago.
Wow. Yeah. So, I mean, then as well, we were definitely not the company we are today. We were struggling back then. We didn't, back then in 2004, 2006, we didn't even recognize the flaws that we had. We thought we had a really good company. But there's nothing like a recession and a credit crunch to show that you don't have that company that you thought you had. And then we really had to become businessmen in 2010. Because I think before then, we were fumbling. We were very successful at what we were doing and putting out a really good product. But from a business perspective, we were seriously flawed. Financially, the HR, that wasn't good. So we never really, I don't believe we had a sustainable business then until the 4 partners that you have today really got involved and committed after 2010.
What is that one thing that you are confident person X or company X cannot do? So when I'm putting the context because I want to find out from competition, when you look at Jendamark and what you guys have been able to do in the past 30 years, what are some of the things that you are confident, whether you're in Germany or wherever in the world, competition can't deliver this like we can? What is that?
I think it comes down to understanding, and I'm not saying that they can't do it, but fundamentally, we have an advantage in that we seek to understand the process better. We seek to understand the operators better, and thereby I think we build simpler and better machines. And it's not to say that those guys are not good at what they do, but we go about it in a different way. And it's even, we've seen customers take their global specifications, say, this specification, throw it away. Let us see what you want to do. What would you do in this situation if this was your assembly line? And those solutions that we offered get taken up, completely disregarding their global specifications, okay, to choose a Jendamark way of doing things. So I think that is what is special about us, is that we think in a very simple, rugged, reliable way that delivers for our customers.
So I think there's a big part of it is our culture of never walking away.
Yeah.
You see, the salesman now is showing the baton.
No, but I say it because it's for me personally, it's what I've learned from Quinton. Quinton will never let a fish go. Like, literally, he will fish that water till that fish is on his hook, in his hands. But it's the same thing when a machine is not, when it's completely broken, it's obvious you got to fix it. But when it's just not quite right, it's so easy just to leave it. But the culture of our company, which stems from Quinton, is still not right. You must fix it. Doesn't matter what it costs, to our detriment sometimes financially, arguments internally about the cost impact. The principle is not right, fix it.
There's one thing here, the financial detriment. People measure a lot of things by just the finance side of things. What you will never get back is your reputation if a thing just works sort of 85%, okay? And I think if you hold yourself to that and make sure that your reputation, because that is something that you look forward to and is going to see you through times where people will remember you for they did not walk away. And we failed miserably at things, okay? A prime example was a production line in China that was, let's say less than adequate, okay? But we went in there, we owned it, it cost us a fortune, okay? But we fixed it, we built stations from here into China within 17 days to make sure that customer, although they were at risk, that risk never bore down on them at the end of the day where they stopped their customer, which completely, even though we have failed miserably, they never forgot, and to this day they're one of our biggest and best customers.
Can I add one more thing?
Yeah.
To the, because I think it's an important question, but again I'm saying it because it's the Quinton's personality that is bred through into the company is, and I think this has only come about because he's gotten older, is we've always been a flexible company. I'll say pre-2010, customer would come with any requirement and of course, we'll do it. And we'll never walk away, but we didn't understand those risks, and so we ended up putting too much risk on our business and then indirectly on our customers' business, because we were doing ointment filling machines, yogurt packing machines,
Chocolate depositors,
hide tanneries, and then catalytic converter machines, engine lines. So we were doing everything because we were very flexible and we were obviously trying to grow the business. And I think that flexibility comes with risk, like I said, on both sides. And what we've learned over time is that we've been able to manage that flexibility, which you need to have, but also be a little bit more rigid in certain things. And that's where we came up with this Lego blocks or building blocks idea, where you design certain machines to a specific very high standard and you keep them in a box. And then you have multiple of these boxes that you can configure together to make a production line that meets the specific requirements. So you're flexible, but also rigid in those critical machines. And so that's kind of been our ethos. So we don't want to be, okay, that's what it is, customer, take it or leave it. But you don't want to be, yes, I can do everything different every single time. So it's that balance between the two. And I think that's one of the key things that's allowed us to be a successful business, manage our customers' risk, manage our risk, and actually for the first time make profit, right?
Yeah.
a sustainable profit. You would have
Sustainable
good profit and then loss, good profit. So now, I mean, we can predict what's going to happen.
So, I mean, I think also the export side of the business and focusing on that since 2010 has really changed the company forever. We were in this horrible cycle with the South African economy and the automotive economy. So you had these highs and lows, both of them dangerous. The export gave us the sustainability, and we were scrounging around basically in those trough times in the automotive period, doing all these other things, like I said, chocolate deposit. There's some creams that we will not mention that Yanesh has packed as well, or didn't pack. So
I did give up on that. That was terrible.
And then have this export business, or seeking export business, and finding out, wow, now we can take all that energy that we had, that we were using, and spreading it very thin and focusing it. And it gave us a laser focus on what we needed to do and be able to come up with these building blocks. And yeah, it changed Jendamark forever.
Yeah.
I have a question about, for both Yanesh and you, Quinton. You've been doing this for a long time now. At what point do you start thinking about, now it's time to give it to the new generation to run it while we ease in a bit?
I wanted to do that, I think, at 35. I failed. Tried at 45. I failed. 55, I got it right. And then he moved. Well, yeah. So I had my succession plan, and he messed it up by becoming the father of the new Odin suite of products. So that's why he's saying that the baton is not. Anyway.
Yanesh, yourself? Have you, or do you still feel young that you haven't thought about that yet?
Nah, that's the furthest thing from my mind. Oh, but handing over.
Yes.
So one thing I've always learned, and I wish I can remember who said it to me. I can't remember. It was somebody either at VW or early on at Jendamark. Said, the day you start a job, find your successor.
Find your successor.
Who was it? I
We
think
live by that.
yeah, I can't
We're
remember.
always looking for our successor.
So and today I sit in a role developing something new, that if I don't have a successor, how am I going to do the next new thing? Because I'm more excited about the new thing. And that's why Jean is there, right? So Jean, before I started this whole Odin thing, I said I need a guy next to me. And that's what Jean is. Jean is my successor. So together we groom this thing, and I'm sure when it's a success, I hope it's a success, I'm going to be, I don't know, something else.
Playing golf, chilling.
No, I don't think so. I think it's...
Why do entrepreneurs not want to chill?
I do want to chill, but I think chill is a means to an end. It's the end. It's not the means. And I think you get excited, you're driven by the means. Like that's
So
that
I think
thing.
we do chill, but in a different way now, okay, is that we make sure that we have personal time. That's the most valuable thing, okay?
Yeah.
Looking after our families, looking after our health. I think that is the biggest gift that Jendamark has given to me, the new Jendamark, is time for me. I think in those formative days, there was no time for anybody, let alone yourself. But since 2010, yes, a lot of hard work until, I think it's still a lot of hard work, but it's definitely changed how we manage our time and spend time with the things that we really enjoy doing.
Yeah, I spent years working every day.
Yeah.
I remember distinctly, the sales office was in the finance, where the finance team is now, sitting there on Christmas Day, working on a quote for Bear HVAC line, which fortunately we got the order. Like if we didn't get the order, I would have been very sad. But I was sitting on Christmas Day. Everyone's like out. But it wasn't like, it probably would be similar for you. It wasn't like, shit, I hate this company. Look at me, I got to work on. It was like, I got to get it done.
Yeah.
Like, what day of the week it is, what time of day it is irrelevant. Like, it's got to get done.
And
So
that's
do
the
it.
type of people that you want around you.
Yeah.
That's with that same passion of, okay, just got to get it done. It's focus here, it's a day in the life, and yes, it is Christmas and all the rest of it, but let me get it done and we can still go have some time. But if you don't have that focus sometimes, like I said, in the past it was detrimental, but now we manage it a lot better. Because the part that he's not telling you is the family side of it, how it affected them.
Yeah.
Okay, we unfortunately, especially in my situation, the sacrifices I made was not just my choice. I took the choice away from my family too. They just had to live with it.
I want to ask again to both of you guys. At some point, because of how human beings in the society, how it's structured, before you're Quinton, you're first the founder of Jendamark, and then you're the director, and then you are this, you are that guy, before you are yourself. And similar to Yanesh, before I see Yanesh, I see my boss first and all of that. How do you find yourself when everything around you is suggesting that we don't want to see yourself, we want to see the guy with ideas, the guy who knows it all, the guy who can solve problems?
I don't prescribe to that. I mean, I hope that people just see me as Quinton. That's the first thing, because everything is projections of you and what people might think, but that's just an opinion. It's a figment of somebody's imagination. Try to be, just be authentic.
I get what you're saying. Obviously, I don't see it for myself, but I would imagine it's there. But I see it when Quinton's walking down the shop floor. I can see everyone's like, "Oh shit, Quinton's coming." Better like make sure things
Start
are tight.
acting busy. Like
No. I don't think we have a culture of faking it. None at all. Fortunately, some companies are like that. But when Quinton walks on the floor, I can tell you now they're checking the bolts are tightened, the ball screws set up fine. Nobody's got their foot on the machine, because Quinton hates seeing a foot on the machine, because it's an expensive thing and you don't put your foot on expensive things. So you can see that. So there's a perception of Quinton, which is a right perception. But I think that
it's an authentic one.
Yeah.
Because those things that they are maybe concerned or maybe stress people out, those are the things that I will address, because it's our business. This is our livelihoods, and everybody depends on that. It's 350 people in this organization, 350 families. So it's a heck of a responsibility. So yeah, I do have expectations, and the quality and the process has to be right. And don't disrespect the machine.
When you it's a bit less now, but when a couple of years ago when Quinton used to walk on the floor, so we used to say, Quinton, you're allowed to talk to the people on the floor, because he would be the guys on the floor wouldn't know how to react to Quinton saying something. So we said we banned Quinton from talking to the guys on the floor, because they would react, because he's the boss, right? So what Quinton would now do is take photos, stand there with his phone, taking all of these photos, and then the managers in the office would know, oh shit, Quinton's on the floor and these photos are just coming of problems and things that he's seen, and the managers would be sweating about that, which is right.
Which was right. The guys on the floor had no power over what was really there or the assembly process, and I'm asking them difficult questions about an assembly process of something that looks risky on the assembly process that had gone through design. But the photograph thing worked excellently.
What do you see the future of Jendamark as?
So, the ability to take what we've always wanted to do, and I have to thank you for that, is with this Odin building a completely new way of being able to interface with operators and many more customers, even outside of the automotive environment. And I think we've heard the term bandied about democratizing manufacturing, and I think that's what I'm looking forward to now, is taking all our mechanical knowledge that we've had, electrical knowledge, combining it with what you've created and the new architecture you created there. And I'm excited for the future, for the blend of this software developed by engineers for manufacturing environments. I think it's different. It's nothing that we've seen before. So yeah, I can't wait to start deploying that. We've seen some of the success stories already, but I can't wait to take it to not just in our environment, but deploying globally on that. That's what I'm really
Do you think
interested
he's going to retire?
Nah, it's not gonna happen. It's not gonna happen.
Give me a chance, okay?
It's not gonna happen.
He may slow down to 6 days a week.
Yeah, it's not gonna happen.
We've got 2 digital businesses that we're trying to start, Odin Education and Odin Manufacturing. Both of those are passions of yours.
Yeah.
Even as a mechanical engineer, the digital side of manufacturing has always been part of the irony of it is I learned about digital manufacturing from a mechanical guy because he explained it from a process perspective. The software is always a means to an end, but I learned it from a process person, a mechanical person that explained why digital manufacturing is important. It's ironic, but that's the truth. Why are those 2 things so passionate for you? It's maybe separately or together or however you feel.
Let's just take the Odin manufacturing. We've always strived to produce a production line for the end customer, and for us the end customer is that operator on the production line. Okay, whether we're going to automate something to make his life better, okay, or we're going to facilitate something, it's to help him with that job. We know that the past history of our country, the problems with education, so we always had a learning element in our, we used to call it PPS, okay, to be able to deliver something to that operator that will make him fulfill his job, and at the end of the day his dreams, and make him happier in his job. So that was always key, and that's why we succeeded, was looking after that operator. And when you look after the operator and that process and honored those 2, the job to the guy who gave you the check at the end of the day was so much easier. Okay, so I always say to my guys, your customer is not the purchasing department. It's the important part of it. Your customer is the guy on the line. Your customer is production guys. So we found out early on, once you engage the operator and show him how to do things better, help him to do things better, our world changed in whether it's automation or semi-automation, it changed completely. And coming from a disadvantaged background, it was, giving that person that acknowledgement that you've done a good job, helped him do a good job. At the end, those assembly lines, when it came for people to choose who they're going to work with, they chose us. They wanted assembly lines from us. And the same with the Odin Education. If you take and you are enabling kids to dream about things and improve their circumstances and their lives, that's what I got. I got it in the form of great teachers, mentors along the way, and opportunities. Okay, I couldn't go to libraries because it was dangerous, either in Corson or Galvandale. There were always elements of gangsters and the mafias and the mongrels those days, and getting bugged and your money taken away or something like that. So I found refuge in Encyclopedia Britannica at my uncle's place. But today we can do things so much better. And I know what those Encyclopedia Britannicas did for me. It awakened something in me, this curiosity of wanting to know more, wanting to learn all the time. And how do we eventually change our country? Okay, 2 things. We need a strong economy, and that's why we're in it from an automation point of view and a manufacturing point of view, to come up with solutions that's going to help the country. And then education, the young ones, just like the fire. And those will be your new entrepreneurs. We're not going to solve this country's problems by merely creating jobs. We've seen how that works. But creating entrepreneurs, that is something really, really special. That is a future that I can buy into. I think anybody should be able to buy into that, because that one entrepreneur, 5, 10, 300 jobs maybe at the end of the day, with maybe jobs overseas and companies overseas, bringing foreign currency into the country. That's what I feel very, very strongly about.
So I'm assuming at different stages, gender meant something different to you as you were growing along. What does it mean to you today?
Yeah, what does it mean today?
Or how's it evolved, maybe, to how you feel it is today, from when you...
Yeah, it was an absolute struggle in the beginning. Not having the right partners to support you, the right vision, the right goal, the same passion. It's very difficult to work under those auspices, because you can't carry everything yourself all the time, and you need people to be there for you when you slow down or you're going too fast, even, to let you know, hold on, stop, okay, we can't take any more. And what we were suffering from as that very, in the formative years, is we were not exporting. It was the cycle of every 7 years, a lot of work and then nothing. So we put ourselves at risk a lot of the time when we had no work, and then put ourselves at risk when we had too much work, trying to see through those lean times. So it was an absolute roller coaster, one that I wish on nobody, because it really tells on your soul and your family. And I think that is the part that I regret I didn't handle better, because my family paid the price for that. I'm sure I did too. I'm sure I aged a lot in those formative years. But now that we have a real company, the most important thing is I have a life now, which I can't say that I had before. So that's the difference between then and now.
You're saying it's not a roller coaster now?
It is a roller coaster, but a roller coaster...
You got a seatbelt on.
With a seatbelt.
Yeah.
A roller coaster where you have people to back you up that have the same vision, again, the same passion, and want to see the same outcome. Whether it be project management, financial, the software guys, mechanical guys, all focus on the right thing. That's a different dream.
Don't need an imagination to understand that.
Quinton, thank you very much for coming to the show. It was really an honor and a privilege for me, as I'm assuming it is for Yanesh. We really, really thank you for your time. I don't know if you're thanked enough for what you guys have started, but it's giving us a livelihood, and that is important.
Yeah, I think that I would add to that, often we don't appreciate what you've done for all of us. We wouldn't be here if it wasn't for you. And so I think we deeply appreciate that.
Thank you, guys. All I can say is thanks right back to you guys. None of this would have been possible without you guys. And as you know, the situations that we've had in our lives, this is not a one-man operation. This is an amazing team that I'm blessed and really fortunate to be able to work with. So thanks to you guys too.